Okay, so yeah, this is week 6. This is the last week of our classes, at least officially. So the topics that I wanted to do today, unless there are other topics that people want to talk about, are some of the more advanced tools that we have in Fusion 360, just to kind of finish the conversation about what are the things that I can do, at least in a basic way, in Fusion, just so that's a more complete picture of what all the three-dimensional transformations we have access to. So I know it's been a couple weeks since we've done Fusion. I'm going to start this example with tools that we already have, and then we're going to go a little bit backwards and then do it with some of these new tools instead, so that you can see different ways of constructing objects in Fusion. Okay, so we're back in Fusion, starting from a blank slate. So again, always in Fusion, you want to start from a two-dimensional drawing that you then make into a three-dimensional model. So we'll click the Create Sketch button. This is how we start a two-dimensional drawing. It'll give us the option of which plane to pick. I'm going to do this drawing from the bottom up, so I'm clicking that Z plane. Just for this example, I'm just going to make 2 rectangles. So we'll just do like a 25 by 100 rectangle, and we'll do 2 of those. So I'm going to go a little bit faster than we did when we were originally teaching this, just because you hopefully have seen all of this before. But if you need me to stop and re-explain something, please stop me. So I'm just using the rectangle tool. I have 2 rectangles drawn in this space. That's all I really need in this drawing for this example. So I'll hit Finish Sketch, and that'll bring us back into three-dimensional space. And I'm going to extrude these upwards. So I'll hit the E key for the shortcut to extrude, or you can hit this button up here, and that'll access the same thing. We're going to select the two-dimensional objects that we want to extrude, so these 2 things. And I can either pull this arrow upwards to use this transformation tool, or alternatively, I can type a distance over here. So I'm going to extrude these 100 millimeters up. So right now I have 2 three-dimensional rectangular blocks. Right? So now what I want to do artistically is I want to create some bridges between these 2 to connect them. So what I can do now is I can go into Create Sketch, and I actually want to create a sketch based on the face of this object. So Create Sketch will work on any flat plane that you have. It doesn't have to be the planes of the original Fusion drawing. It can be any flat plane. So I could make a sketch on top of this. I want to make a sketch on the side of this, and you'll see why in just a second. So now I'm looking straight on, and I'm in a new sketch. Fusion's still going to show me that I have these 2 rectangles, but I need to use an additional tool to tell Fusion that I want to access the actual dimensions of these in this new drawing, which is the Project tool. So I can hit P to quickly access Project, and I want to project this line and this line from these objects into my drawing. And I'll hit OK. If you don't remember P for project, you can always go into Create, and then there's Project/Include in here. The other way that I could have done this is using the Intersect tool, but I'm not cutting anything with this plane, so it doesn't need to be intersecting. So now what I'm going to do is I'm going to draw a line that starts from the top of this and goes down to the bottom of this. And you'll see we get that square. That's that kind of indicator that Fusion's going to automatically put a constraint, that coincident constraint, so that this line and the line that I've projected must intersect somewhere. That's what that box means. The other thing I'm going to do is, instead of specifying a dimension, a length for this line, I'm going to actually hit Tab so I can go over and specify the angle of this line. Now it's giving me the angle off of the flat top of what we've projected, but I know that just because of printability, I want this to be 45 degrees or more. So 45 degrees at 180, that would be 135. So I want this angle to be 135 degrees.
Why would tab be the kind of command one would use?
So I'll delete this just so we can do it again. When you're in a tool that has multiple potential things to define, so you can see right now we have the distance of the line is the thing that we are telling Fusion, but you can see there's another box for the angle. So when you are in the process of drawing something in 2 dimensions and you want to switch between the options for what you can constrain, you hit tab in order to do that. So tab will go back and forth between specifying the distance or specifying the angle. So that's what that's there for. So I'm going to specify the angle. I'm not worried about the distance. You'll see there's a little lock next to it now which says Fusion, regardless of the length of this, is going to make sure that it's 135 degrees. And again, I'll just go make sure that it is coincident with this other line that I made. So now we have a line that connects these. I'm going to make another line. And we'll use constraints on this just as a refresher on that. So I'm going to be pretty willy-nilly with how I draw this line. Right now it's blue. Remember that the filled in blue means that Fusion considers this a closed 2-dimensional form, which is important for using the transform tools. We'll need a closed form in order to use the transform tools. But the line itself is also blue, which means Fusion doesn't have enough constraints to be able to know exactly where in space this line exists. So I'm still able to move this around. But I can put some additional constraints on this so that Fusion will know exactly where it is. The first one that I want to use is this parallel constraint. So this lets me click 2 lines and say these 2 lines need to be parallel. So that's the first constraint that I can put on there. Notice it's still blue because that has fixed the angle problem of the super quick line that I drew in, but I can still move it up and down. So the next thing I can do is specify the distance that these need to be apart. And that's either over here in the create, I can say sketch dimension, or the quick key for that is D. So now I'll just click this first line and the second line, and then it'll let me specify I want them 5 millimeters apart, let's say. So now I have a fully constrained line here because it's now black, so Fusion knows exactly where it belongs. It can't be moved anymore.
If you wanted to move it, can you unconstrain it so that you say, oh, I made a mistake?
Yeah, so you'll see when you're in a drawing, Fusion will show you all of the constraints that are happening. So for example, these 2 lines have a parallel constraint. So if you actually click on the constraint itself, you can delete just the constraint and that'll go away. And so now these aren't parallel anymore. If I click this point here, you'll see it's coming up with that coincident constraint. So I can click this and delete it, and now this is going to be movable. So that's, yes, you can always remove constraints later just by clicking on the thing that has those constraints, clicking on the little icon of the constraint itself, and just hitting delete.
But I'm sorry, can I just follow up? But if by removing the parallel, that did not make it unparalleled. It wasn't like wood? Yeah.
Because there's still another constraint on there that's helping with that, and that's that 5 here, right? So that is driving a lot of what's happening here.
Until you create a new constraint or go back to the old.
It's going to try to use as many as it can to figure out what the drawing is.
It's okay. It's like that's the question that I can limits them.
Yeah.
Even with parallel, even with being 5, you still can move it around.
That's correct. Yeah, because it could be 5 the other way, but because it is also constrained to these 2 vertical lines, it can't move that way anymore. So that's why Fusion's turned it black instead of blue. If there was a way that you could move it somewhere else and still fulfill all of the constraints that you have on an object, it would still be blue. So I'm going to finish that sketch. So now we have a closed form by that light blue fill-in that connects these 2 things. So now I can use extrude here, and I want to extrude it this way by 5 millimeters. Notice just because of the way that the drawing is facing, Fusion actually considers this minus 5 millimeters. That's okay. Just look at the drawing that you're doing to see, just to make sure. All right, so okay, we've got that. The operation we want to do is join. So that's actually going to connect the transformation to the other parts of the model. So when I hit OK, you'll actually see over here in our tree of things that we've created, before we've done this, we had two bodies, this rectangle and this rectangle. And once as I click OK, it's actually going to only go to one, because now this is all one piece.
What
I have
happened?
a question.
Go ahead.
So let's say you would create a sketch with two rectangulars, and then you would attach this kind of diagonal part of this between them. However, you choose to do it separately because you're extending it on a different height, extruding it different height, or why you didn't do this diagonal line as a part of the first sketch.
You could do it that way, but because I extruded these two up from the bottom, and this starts in the middle of that form, this is not an easy thing to define from the bottom plane. That's why I chose to do it from this plane instead. But thinking through those kinds of problems is part of how, like, that's part of the skill of modeling, is what's the easiest way to get to the shape that's in my head using the language that Fusion is giving me to describe it.
And one more question.
Yeah.
You hadn't, you had two bodies, but your first body was actually two separate units. And, you know, then you joined them and you had one body again. But the two separate units were never joined. Were they only joined in the sense that when you did your first sketch, you had two rectangles?
That's correct.
Okay.
So even though they were on one sketch, because they're not physically connected at all, Fusion will make two separate bodies from them. And then because Fusion knows when I did this extrude that those two bodies are now physically connected, it creates one body out of what used to be ostensibly three things, right? The first rectangle, the second rectangle, and the span that's going between them. I don't have to do that, right? If I go back into my extrude, I can tell it that I don't want it to join them, I want it to make a new body. And that's fine too. Like, this still works, but now I have three bodies, and I can't export these to the slicer like this. The slicer is expecting one body to be exported. So I could either do this and then later come and select all three of these and use the modify combine, which will basically do the same thing. So now we're back down to one body. Or you could export all three bodies separately and have to arrange them in the slicer. And that might be something that is the way that you want to print it anyway. So even though I want to view it cohesively in Fusion, I know just from the way that I'm constrained by the printer, I might have to print it in separate bodies. That's an option that you have too. So I'm going to undo that. So we're back to here. So we'll re-extrude this. We'll go 5, join together. And the last thing that I want to do, right, I could make another drawing and then extrude that and make another drawing and extrude that and make another drawing and extrude that. But there's an easier way if you've done an operation, one of these transforms, and you want it multiple times, and that is the create pattern function. And there's really three in here that are useful. There's the rectangular pattern, so that is anything that you want to repeat on a straight line in one or two axes. There's a circular pattern, which is where you want to repeat that thing around an axis. And then there's a pattern on path, which is if you have a line that you've drawn in a drawing that is not straight, you can use pattern on path to repeat a feature following the path of that line. So we're going to use rectangular pattern here. It will default to bodies, and we only have one body, but one of the things that you can actually do here is select things by feature. And a feature is something that was created by one of these 3D transformations. So the feature that we want to select here is the thing that we made from our extrude, which is this span. And then the axes that I want to use is this straight line here. And you'll notice it's given me two arrows, right? It's given me an arrow going in this direction and an arrow going down, because rectangular can repeat in 2 dimensions. So I want to go this way. out to the end of my rectangle. And you'll notice it's given me a couple things here, which again, I can go between with tab. I can go the distance and the quantity that I'm repeating them. Right? Now, for axis 2, I don't want it to repeat in that direction at all, so I'll turn that back down to just 1. And here I can specify I want more than 3 for this shape. Maybe I want 5 of them. And then I can hit OK. And now I have a form that has 5 spans going down my shape.
Well, why did you choose to make one body before you just did the transformation you did?
So you could do it the other way, right? So if I had this as 3 bodies, I could select that middle body of the span. That I would select the new body when I created it using the extrude transformation. Then apply the pattern on that body instead of that feature. Repeat it the same way, and then use the combine tool at the end. That would get you to the same result. And if that's the way that you prefer to work, that's fine.
So what happened to the 5 millimeters? That, you know, you have a plane in the front and you repeated the pattern, but if you repeat a pattern that includes the face, wouldn't you be adding?
Yeah, so you'll notice, if I go back into this operation, the distance that I've repeated over is actually 95 and not 100, because it's taking into account that 5 millimeters that we have as part of our object. So that's what's happening.
So it's smart.
It tries to be.
Okay.
So that is using most of the same tools that you've already seen with what we've been doing in Fusion. So we used extrude, we used different drawings on different faces, we've used project. We took a little bit of an aside into the patterning tool, so that might have been new, although I think I touched on that the first time we talked about Fusion. But I want to start talking about some of the different 3D transforms that we can do here. And the first thing that I want to talk about is the sweep command. And what the sweep command does is it lets you take a 2-dimensional drawing and move it along a path and use the kind of ghost of that to create a 3-dimensional object. So you can think of, you know, as a 2-dimensional shape is flowing across that path, it's carving out a new 3-dimensional shape behind it. And the way that we could express this here is to say, well, these spans right now are rectangular because I used the extrude. It just came straight out. But what if I actually wanted these to be triangular or oval or some other shape? Right, so I'm going to back this up a little bit. I'll delete the pattern and I'll delete the extrude. We're still left with the sketch here, and I'm going to leave this because it turns out for sweep, you need 2 different things. The first thing you need is the shape, the 2-dimensional closed form that you want to sweep. And the second thing is that you need the path that you want to sweep it on. So for this example, this top line is the thing that I'd want to sweep on, and I'm going to now draw another sketch to define the shape that I want to sweep with.
And the sweep line, can it be on a straight line?
No, it can be any shape you want. So it could be, you can use that Bezier curve to make this arbitrary. It could be part of a circle. It could be, you know, some kind of angle. Sweep can go, as long as you can define that path, it can go on any path you want it to. And we'll look at that. We're going to start with a straight line though. So I'll go in here and create a new sketch. And I'm going to create it perpendicular to the path that I want. You don't have to, but you'll see why it makes sense to do it perpendicular. I'm going to project. So you can see here, I want to project this point because that's the point that I'm going to use as the start of this as my sweep. And the other reason I want to project that point is now I want to hide these bodies because they're distracting to me. So now I'm looking straight on, and I'm going to create the 2-dimensional face of the thing that's going to follow that diagonal line down. I'm going to do a pretty simple one here just for being quick about this. So I'm just going to make a triangle here. And again, I'll be a little sloppy, and then we'll use constraints to make this a little better. Although maybe you want your span to be sloppy, that's fine too. But again, just in terms of practice and going through some of the stuff that we've already seen, I know that I want this bottom to be 5 millimeters to match the general shape that I had before. So we'll define that as 5. I know that I want this bottom to be parallel to the ground, so I can use this horizontal vertical constraint and click that and say that I want it to be parallel to the ground. The next thing I want to do is actually make sure that this point is in the same line as this point, right? And the way that I can do that is by drawing another line between these, that it's a construction line. If you remember from before, a construction line is a line that we can apply constraints to, but won't get included in any of the transformations. So I'm going to connect this line and this line. And then just like before, I can make this parallel to the ground. So now we have that. And then the last thing that I want to do is I want a coincident from this line to the edge of the that's not the last thing, actually. There's one more thing that I want to do. So now I know that it's connected to the very edge. And finally, in order to make this an equal triangle, I'm going to make the distance of this construction line 2.5 millimeters. So now I know that this is going to be halfway in between. Now you'll notice this is still blue because there's ways that I can move this around, like, like up and down, because I didn't constrain how tall it's going to be. It's going all over the place. We could define that, right? Like we could take the length from here to here and define that. So maybe we also want this to be 5, and that should lock us in. Good so far?
Yeah, but why not, I mean, maybe this is what you need to do, but why not make a parallel line at 5 millimeters, pull it up so it's equilateral?
You could do that too. Like in ceramics, in 3D modeling, there's 8 different ways to get at the same shape at the end. This is how my brain at this point in time decided to interpret the constraints on this. But yeah, if you can get to something that's fully constrained, regardless of how you got there, Fusion will be happy.
Well, but you can't use you wouldn't be wanting to use the construction feature because that's really not constraining?
You can constrain non-construction lines using construction forms. In fact, that's the whole reason that construction lines exist. It's just that they're not going to get included in whatever transform you're doing. So notice I have a closed form with this triangle, but the closed form between my construction line and the edge of this isn't, because the construction line doesn't get to make closed forms. It's not something that you get to use in a transform. It's just there to help us line up this point with this point. So now we're back in 3D space. Let me zoom out a little bit, and I'll turn the bodies back on so we can see those too. Right? So now we have this triangle that we've made, and we also have the path that we want it to follow. So now over here in the Create tab, which is where all our transformations are, we have this new tool called Sweep. The first thing it's going to ask you for is the profile of what you want to sweep, and that profile is our triangle. And the next thing it's going to ask you for is the path that we want it to follow, and that path is going to be this top line here. Notice there are a couple things that we can do with this. The orientation means, do I want to keep the shape perpendicular with the line that I'm making? So if it curves around, do I want to change the angle of the shape as it's sweeping? Or do I want to keep it parallel and sweep it like this? Depending on the shape you want to make, either one of these could make sense. For our purposes, because our line is straight and our drawing is already at 90 degrees to it, this won't matter, but if we started to make a curve shape, you'll see. And I'll put a curve shape in here so that you can see it. So we'll hit OK.
And it should touch this kind of the sweeping line. Or
It doesn't have to, but if you want it to join these two bodies, it should.
yeah.
So now we have the same kind of idea as what we did with extrude, except now the bridge between our two objects is a triangle instead of a rectangle. And we can go back through and go into our patterning tools and say rectangular pattern, and we want to use a feature, and we want this as our feature, and the axis is this. And we want to go back 95 degrees. And we want to make 5 of these or 10 of these or whatever. So we'll go up to 8 this time. So now we have a similar form, but because of the sweep tool, we get to make it using triangles instead of rectangles.
So right before you made that into one body, what the point at which it joins the plane looks like just a single point, but it becomes the entire triangle once you join it up.
Yeah, Fusion knows that that sketch plane is on this face of our model. And that sketch plane and then where it ends up, which is over here, are also on the same plane. So Fusion is smart enough to know that those things are touching, so we want them to join. They don't just have to be touching. If you make a path that goes into an object and use that join command, Fusion is smart enough to know that, yeah, even though it extends into my object, I can just ignore all of that, and the join will still just make it one solid object. If you use new body instead, it won't do that. It'll have an object that goes into another body in Fusion, and then you end up with similar things that happened in Blender, where if you try to put those in the slicer on top of each other, weird things might happen. Although the easier solution in that Fusion has that Blender doesn't is if you use this combine tool, it is smart enough to ignore things that are inside of each other. So if you are not quite sure how to get a surface to touch, it is always better to just have the line go farther than it needs and use the join commands. And for example, if you're trying to do this onto a cylinder, there's no way that you could have a plane that is touching in a 3-dimensional way on a cylinder. So just have that path extend into the cylinder and then use join so that you get all the way up to the edges of the cylinder. And so we can do that. Let's do that instead of a curved path. I think you can understand what a curved path is just to explain it using Fusion. So let me delete all of this, and we'll start all the way from the beginning. We'll create a sketch. We'll create a cylinder now. And this will be a good way to get into construction planes too, because we'll need a construction plane to do this. I'm going to extrude this 100. So here's our cylinder, right? And now I want to sweep something into this. So the first thing I'm going to do is try to draw the profile that I want to sweep. And you'll notice if I want to create a sketch, there's no straight face on the cylinder that I can use to make a sketch. It's curved. It doesn't have anything flat to reference. I could make a sketch on the top or the bottom, that's fine, but it's hard to make a sketch on the side. And Fusion actually provides us tools called construction planes that let you make a drawing plane for a 2-dimensional sketch in other ways other than just faces that exist on bodies that you've made. So if we look over here, when we're in the 3-dimensional space, we have this construct section, and this is all about making planes, lines, and points based on other things in the drawing that are not just flat. So one of the big ones that you'll use a lot, and that's why it's in the top part, is the offset plane. This is to say, hey, like I know this is a flat plane, but I actually want to draw 10 millimeters above it. I can click this and then tell Fusion, make this plane, above it. So now I have a way to draw on something that is not directly on my model. That doesn't help us here, though. We need a different thing. And the thing that I want to do is where is it? Tangent plane. So now I can click this, and you can see it's going to give me a drawing that is tangent to this cylinder. right? So now I know this drawing plane is face on with the cylinder, like we drew up there. You can have Fusion change the angle of this if you wanted to do something a little different in terms of how your model's already oriented. All we have is a cylinder, so it doesn't really matter to us, but you could think of this as something more complicated that you'd want to rotate which tangents it's using. But okay, so now we have what is kind of, to me, akin to the construction lines that we draw. Here's a construction plane. It's something that we can use to help us model, but it's not going to be included in the transformations. So now I can say create sketch, and I can create a sketch on this new construction plane that I've made, right? And let's create something, I don't know, weird and curvy. Cool. So we have our weird and curvy shape, right? And I could extrude this, right? But to your point, Liz, that is not connected to my cylinder. There's this gap here because it's not flat. And you'll notice, even if I hit join, it's not going to do it. Or maybe it might like right along here. So it is still counting this as one body, but this is not what we'd want.
Can be extruded in the other direction?
Yeah, so there's two ways to solve this, right? The first way is, again, if we hit undo, we'll do it with a sweep. So I'm going to make another drawing. This time I can make it on the top. I want to look straight down. And I'm going to make a line that goes from the center of my cylinder out. It doesn't really matter, but it'll be out past, it's however long you would want this to be extruded. Finish. And so now I have my shape. I can use the sweep tool to select the profile and the path, which is now this new line. You'll see that it defaults to cut because it knows that it's intersecting, which that could make some cool stuff too, right? Because now we have this shape cut out of my cylinder, but I can actually still use join, right? And now you'll see that it is actually going all the way up to where my cylinder is. And if I hit OK, now we've got that solved.
So when you say join, that's kind of extensive.
Join is a way of, remember in Blender when we had that cat and the monkey head and we were trying to get them to line up and we had to remesh everything so that it didn't have all the geometry that's on the inside? That's what join is doing just inside of Fusion. It's doing it using formulas. It's not doing it using points, but you can think of it as equivalent. So that's one way that we could do this. The other way that we could do it, and this is an easy example of sweep because this is a straight line that's coming straight out, right? If I made this line a different angle, it's not going to be the same as what we could do with extrude, right? So like if I go here and instead of having this be perpendicular, right? So I'll delete that constraint. I wanted it to be off at this angle. Or let's even do a more complicated one, right? So let's delete this and we'll do a curve here too. So we'll start at the center and we'll do a curve like this. Finish sketch. And now we'll sweep on that. I made it too curvy. So the error that it's giving me is that this would be self-intersecting from the way that it's curving around. So I'm just trying to fix that for this example, but maybe I got overzealous with how curvy this is. Sorry for coming up with examples on the fly. So let's make this less curvy here. So now we have this bendy shape coming through. And you'll notice this is that perpendicular function, which means that you can see that it's changing the angle of my shape as that bends through the curve. If I were to make it parallel, you'll see it doesn't do that. And that does have ramifications for how the shape goes, right? Because it's going to cut a slightly different path if it's turning your shape versus not turning your shape. So that's what sweep does. There is one more thing, though. If this wasn't a curvy path and it was just an extrude, so we'll get rid of this path and we'll go back to what we were originally doing. So we'll extrude this. You can even hit join. That's fine. And we have this missing face again, right? There's another option that we have in extrude that we can select a face, and there's this here that says extent type, and that's the only thing that we've been using so far that just lets you specify how far you want something to extrude, right? There are other options here that we have though, and the one that we want to use is to object. So that says I want this face to extrude as far as it takes to get to something else. So now I can click the cylinder and you can see that it has now filled in that blank section. We'd have to do this on the other side too, but that's just an example of where we could go with that.
So from a printer's perspective, that would be far more desirable than having something on the interior.
Correct. In terms of printing, this solves the issue of, well, with the sweep, using join, this is going to result in the same thing. It's not like Blender where there's points inside of this model. Fusion is good enough to handle all of that for you. Same with if you end up with multiple bodies and then use combine, it's gonna fix that for you. So that is sweep and how you can use a arbitrary line to move a two-dimensional thing around to make a three-dimensional shape. This also gets interesting, so I'm gonna delete this weird thing that we have sticking out of here, because sweep allows you to do things with cuts as well. So there's cool things that you can do to make profiles similar to revolve that you can also get away with in sweep. So for example, if I use this construction plane and say plane along path, what this does is it makes a construction plane that is orthogonal to whatever path you tell it. The path that I want my plane orthogonal to is this, the top of the cylinder. So you'll see now I have a plane that cuts at a 90-degree angle to whatever path I've selected. And where on the path is specified by this distance. So you'll see if I move this, the distance will change there. So
But that's irrelevant.
irrelevant to a cylinder.
Yeah.
But if you have an arbitrary path, it is relevant about where orthogonally do you want that plane to be.
Yeah, until you create the rest. Is what I
Right,
was gonna say.
exactly. So now if I go to create sketch, and let's just create, again, some arbitrary shape here. Cool, finish sketch. I can use sweep to now use this profile to cut off an interesting section of this cylinder. Right, so now, oh, I didn't even get it all the way. So now we've got multiple bodies where it cut into the cylinder and left just a little ring of something left behind. So you can see like sweep can get pretty interesting, not only using it to join, but also using it to cut things. All right, so the next thing that I want to talk about is loft. So loft is a way that we can tell Fusion that we have two-dimensional drawings, and we want it to do its best to smoothly connect those drawings into a three-dimensional shape. So again, we'll start with our cylinder here. So this has a circle. If we're looking straight down on it, this has a circle as a two-dimensional top of itself. We're going to use that offset plane idea to create a new drawing that's, a little bit higher up than the cylinder. Create a new sketch onto this plane, and we'll do the classic of making a square that is in, we'll do a rectangle because I'm too lazy to try to make it a square. We'll do a rectangle that is now floating on top of this circle, right? So now if we go to create and we go to Loft, what we do is we tell Fusion, I want to connect this two-dimensional thing to this two-dimensional thing, and I want you to try to do it as smoothly as you can. So you'll notice it's created these compound curves attempting its best to connect a round circle to a square. It doesn't have to be a square. It, again, could be one of those arbitrary curvy objects. And there's some additional things that you have control over how it's making these connections. When you do a loft, Fusion defaults to this connected state, which is basically what is the shortest path that I can take that makes a smooth curve between these two-dimensional objects. But you have some other options. So you can say that you want it to be tangent on either side. So profile 1, that's the circle, and by clicking tangent, you can see now it's made sure that connection is actually tangent into the other curve. And you actually have some control over how strong that tangency is, right? And I could do that on this square too, although that might make it a little strange. So yeah, now you can see that that is also tangent here, and I can control how tangent that is as well.
So it already joined them?
Yeah, these are already joined. You can make it a new body if you wanted to. There's nothing to cut, so we wouldn't be able to cut. But if we hit OK, now this is one body, right? We could put this in a slicer, and it would slice an interestingly cylindrical to rectangular vase if we wanted it to, with these cool compound curves. Something interesting that you can do with Loft is that it doesn't even have to be a two-dimensional drawing for this to work. And this is something that Irina already saw a sneak preview of. If you want to make something like a dome, one way that you could do that is by revolving around an axis, right? I could use the revolve tool, make a slice of my dome, and then revolve it. The other thing that I could do, and I'm going to go into that sketch of the rectangle I made, is, let me delete the rectangle, is instead of revolving around a curve, I can loft to a one-dimensional point. So I'm going to go over here to the drawing things that I have with rectangle and circle and everything else. In here, I have the ability to make a point. So now I can make a point as my drawing. It's the only thing that's in my drawing is a point. Fusion hid that because I was using it with a transform. So here's my point. I can go into Loft and say I want to create a loft from this cylinder to this point, right? And again, there's some defaults here that by default Fusion will connect it as sharp. So it's basically like a cone, although this is offset because I made my cone offset. But I can also say that I want that to be tangent. And again, I have control of this tangency, so I can make different curves based on the strength of that tangency.
Can you move this point at this point to see what will happen?
Yes, although I'd have to move it in the drawing, right? So here's our three-dimensional form. I can go back in the drawing and then move this point somewhere else. So like maybe over here, and then say finish sketch. And so now we have this.
Can you, I'm just envisioning another glass I was going to try to make.
Mm-hmm.
Can you take that object, straighten it up as a cone, make it go through zero,
Mm-hmm.
and then can you flip it?
Yeah, you can always flip it.
Yeah, you can flip it and then, pull it in. I don't remember the command already. Stretch it into the center.
Yeah, we could do that. Let's do that just as an example, right? So this is lofting to a point.
So can you make the point at the
Yeah, so
zero?
let's do that, right? The way you do that is just by having multiple drawings. So let's delete that point that we had off to the side. We'll create a drawing here, and this is where we'd put our point, right? We could put our point here. And now we'll use our offset plane make that up somewhere, make a new sketch on that, circle here, or wherever you'd want it to be, finish. So now we have the two faces that we'd want. We'll go to Loft, and we'll loft from this circle to this point. Now right now it's a cone, but I don't want it to be a cone. I want to mess with tangency, right? I'll have this flare out. I'll have this be directional, right? So now you can see there's that. I don't want it to be a new body. I want it to join, hit OK. And here's our, what is probably not a printable, but at least interestingly shaped thing, right? If I wanted that point, let's do that. If I wanted that point, instead of on the face of this, to be somewhere inside it, let's do that. So we'll delete this. We'll keep the sketch that has our circle on it, but we'll get rid of the sketch that has our point on it, which is this one. And instead, we'll do an offset plane. We'll do it below that face, right? So we'll go down here, hit OK, make a new sketch on that, make a point. We'll make a point here, finish. Same operation that we did before now, loft from this circle to this point. I didn't actually click loft, so that helps if I do. Again, it's going to default to cut because it knows it's intersecting, and you could get some interesting shapes by having it be cut, right? So if I go back and make this point tangent, the shape that this is cutting into the top of the cylinder could be interesting anyway, especially with some more curvature here, right? So now I have an interesting cut in here, but to Liz's example, let's actually join this.
How do you do join? I kind of keep missing it.
Yeah, so this, in most of the transformations that you do, they will almost always include this operation right here on this menu.
I see. So it's from the loft.
Yeah, so in the loft, as I'm creating this three-dimensional shape, I can tell Fusion what do I want to do with it. I can have it join with anything that it's intersecting. I can have it cut anything that it's intersecting, or I can leave it as a new body. So now it's separate, and there is going to be overlapping geometry. You'll have to deal with that at some other point, usually by using the combine tool, but maybe you want it this way for some other purpose.
So what is the difference between, like, when you say combine and join? What's the?
Yeah, so if I do join, right?
It can be done only as a sub-menu from all these operations.
No. So let me undo that, and we'll redo that loft, right? So let's do this loft from here to here, and instead of join, we'll say new body, right? And so you can see they're intersecting. If I mouse over this, it's got that gray area showing that it's inside. If I turn off the cylinder, you'll see that that cone is a full cone.
Yeah.
There's geometry inside of this cylinder. They're intersecting. If I want these to be one body, I can select them both and hit combine. This is the same thing that would happen is if I would to just do this from the loft, that operation join directly. This is just a way of doing it later. So I can hit OK. Now it's one body. There's no intersecting. It's just one shape.
But to do combine, they have to be touching at least, right? Or you can.
That's right. Yeah, combine will take geometry that is intersecting and make it into one cohesive geometry. If you had two separate shapes and you hit combine and they weren't touching at all, it would leave them as two bodies. Does that make sense?
Yeah.
And to your point, Liz, if you wanted then to have a smoother transition from this conical section into the cylinder, you could use one of the three-dimensional modifications called fillet, click this circle, and then pull out a smooth intersection. And now you have an even more interesting shape. This might be printable, although I don't know if it's interesting. It's weird. So that's both things that I wanted to talk about. That's sweep and that's loft. We have about 45 minutes left. I am happy to leave you some time to work. This is the last session, so if you want to print something, now is the time. although you're all in the open studio anyway, so it's not like the printers are going anywhere. But I will be around for questions, or if you want to work through some of this yourself on your computer, I'm happy to answer questions about how it goes. Again, thank you for all being in the session. I had a lot of fun. Hopefully you had a lot of fun. I know there's a lot of information, and yeah, again, I'll be around, so don't think I'm going away, but this is the last session, so.